Okay, so the second example is this. You've got to find the x coordinate of the point on the graph of that function, x times e to the power of x, with a gradient of 2. So recall, you need to differentiate to find the gradient. So I'm going to change the notation here, just to remind you, they're kind of interchangeable anyway. So I could say, call that instead of y, I call it f of x. And then when I differentiate it, now you don't learn how to differentiate this sort of function. So you've got to do it on your calculator. But remember, that's the original function. And this is the function of the gradient as it goes around. When you differentiate it, the gradient function will give you the gradient of the original function at any point. Now your GDC can graph the gradient function. So what we're going to do is we are going to graph it. And then after we've graphed it, we're going to make it equal to 2 to then work out, because if the gradient is equal to 2, that's equivalent of the y value we're going to see. And if we make the gradient function equal to 2, we will be able to immediately see the corresponding x value. So let's do that. Oh, sorry, I'd have been practicing this earlier, so I'm actually going to delete that. So just a reminder, one way you can delete that is go to Actions and Delete All. Right, so I'm going to start again. So I'm going to press Tab to open up the function. Then you go to your special place, which is next to the thing that looks like a book. And you've got all sorts of fun stuff here. And then you click on your derivative. You're differentiating with respect to x. You're differentiating variable x. And here we put in the actual function. So it was x times by e to the power of x as e. Done. What that noise was. Okay, so this is not the original function. This is the gradient function. Afterwards, perhaps I'll draw the sketch the original function so you can see what that looks like as well. So this gives us the values of this give us the y values give us the gradient of the original function at particular points. So if I want to work out what the gradient is when y equals 2, then I'm going to have to type in the line y equals 2. So I'm going to press tab again. So if I draw in the line y equals 2, that intercept there will be y equals 2, and it will give me the corresponding x value. So you've got to work out the intersection. So go to the left-hand side, go to the right-hand side, bosh. So as we can see, so when y is 2, x is 0.3748 or 0.375. And that's it. So that means that is the corresponding x value. So that is the x value when 376, I want to say. Let's go back, double check. 0.375. Close. Okay. So the important thing there is being able to graph. We looked at this earlier. Being able to graph a gradient function. At the time, didn't know how. So I've learned now how to do that, and that is how you can draw the gradient function. So this is obviously very useful. If they ask you to draw the gradient function, your GDC can just do it very simply. I think I did promise you that I would plot the original function just so we can compare them. So the original function is x times e to the power of x. So there's a little treat there. That's a crazy looking one, isn't it? So that is the graph of x times e to the power of x. Right, okay.